Okay, so we are in 14.4, power and efficiency. So we saw in the previous video that power is equal to du dt. It's the amount of work, it's the rate at which work is done. And we saw that this, if we look at du, we know that it's f dot dr divided by dt, and we know that this becomes f dot v. So power is force times velocity, okay, and it is joules per second, or it's watts. Those are the units, okay. So that was the background. It's the rate at which work is done. But now what we want to look at is something called efficiency, or mechanical efficiency. And it's defined by how much power can you get out of the system if you've put in a certain amount of power into the system. So this is P out over P in. Okay? Now, why do we consider this? It is because there are always losses in a system where there is friction. Okay? Wherever there is friction, we know that friction, we'll get to this in the next section, friction is a non-conservative force, meaning that friction does work on your system. You can't regain that energy. You've lost it. Okay? So because it's primarily because of friction that our system has losses. We lose energy. We can't get it back. So within an engine, for example, because of all the parts that are moving and causing friction, we have losses. We lose energy due to friction. So the power that we will get out of our system will always be less than the power that we put into our system. Always, always, always. Okay? Machines consist of a series of moving parts. Frictional forces will always be developed within the machine, and as a result, extra energy or power is needed to overcome these forces. The efficiency of a machine is always less than 1. Okay? So, another way of expressing it is not only looking at power out over power in, but looking at energy out over energy in. Why is that? Well, if the power out and the power in are over the same time interval, then we can just get rid of the time and we have energy out divided by energy in. But I hope you get the concept, guys, is that we put a certain amount of energy, put a certain amount of power into our system, but because of losses due to friction, we will always get less out than we put in. It's like doing bank transactions. You put in $100, you put in $1,000, whatever, and you do a transaction. The bank, which is friction, takes money from you, and you have some losses when you do a transaction. Okay? All right. See you in the next video.